4.5 billion years. That is how long Earth has been turning. Complex life has walked, swum, and crawled across its surface for 400 million years. Dinosaurs ruled for 150 million. Human industry has existed for 300. What if we are not the first? We assume no civilization came before us because we have found no ruins, no ancient factories, no buried highways. But the math is strange. Our entire industrial age occupies less than a single heartbeat in Earth's lifespan. A civilization that rose and fell 50 million years ago would have had its cities ground to dust, its metals dissolved, its monuments dragged into the mantle by tectonic plates that move a few centimeters each year. The Earth is not a museum, it is a recycling system. Our oceanic crust older than 200 million years does not exist. It has all been pulled back down and melted. Less than 3% of the planet's surface holds our cities. Less than 1% of all species that ever lived left fossils behind. Absence of evidence is not evidence of absence, not when the evidence itself gets erased. The question is not whether ancient ruins survive. They cannot. The question is whether something else remains. A chemical fingerprint, an isotope signature, a strange spike in the ancient rock that we have been looking at all along without knowing what we see. If you enjoy what comes next, consider subscribing and leaving a like. We begin now. You are standing on a beach at night. The ocean is black. The sky holds no moon. Behind you, the sand stretches into darkness so complete you cannot see where it ends. Reach down, scoop up a handful of sand, feel the grains press against your palm. That handful is everything. Every pyramid ever built, every empire that rose and crumbled, every war, every treaty, every love letter, every grave, agriculture, writing, mathematics, the wheel, all of it. 10,000 years of human civilization compressed into what you can hold in one hand. Turn around. Look at the beach behind you. That darkness stretching to the horizon and beyond represents 4.5 billion years. The sand beneath your feet runs for miles you cannot see, miles you cannot even imagine. And somewhere in that black expanse, buried under grains beyond counting, a question waits. Try to picture the scale. If you compressed all of Earth's history into a single calendar year, the planet would form on January 1st. For months, nothing but molten rock and poison sky. Life appears sometime in late February. Simple cells, bacteria, nothing you would recognize. The entire summer passes. Autumn comes. Still just microbes drifting in ancient seas. Complex life finally crawls onto land in late November. Dinosaurs appear around December 13th. They dominate the planet for nearly 2 weeks of our compressed year. Then, on December 26th, an asteroid ends their reign. They never saw it coming. Mammals inherit the Earth. Primates emerge. The continents drift into familiar shapes. Humans arrive on December 31st. Not at dawn, not at noon. In the final minutes before midnight, every pharaoh, every Caesar, every king and queen who ever lived, every cathedral, every skyscraper, every road, all of it happens after 11:59 p.m. And industrial civilization? The factories, the cars, the satellites, the nuclear reactors? Less than 1 second before the ball drops. You would blink and miss us entirely. This is not metaphor. This is not poetry meant to make you feel small. This is math, raw, cold, indifferent mathematics. Consider another way to feel it. If you sat down and counted out loud, 1 number per second, starting now, it would take you nearly 5 years to reach 150 million. 5 years of counting, every waking hour, to span the length of dinosaur dominance. Our oldest stone tools date back only 3 million years. You could count that high in about 35 days. Yet we have physical evidence of our existence for a sliver of Earth's history. The tools our ancestors chipped from rock, the bones we left behind, the paintings on cave walls, that is our trace. That is everything we can prove about ourselves in the geological record. Everything before that handful of sand, we assume it was empty. We assume no one came before. We assume we would know if they had, but absence of evidence is not evidence of absence. That phrase sounds like philosophy, an intellectual game, a clever thing to say in arguments. Yet when you apply it to geology, it becomes something else entirely. It becomes terrifying. We found nothing, so we concluded nothing existed. That logic works in a courtroom. It works in a laboratory. It does not work when the timescales stretch past comprehension. And it does not work when the very mechanism that might preserve evidence is the same mechanism that destroys it. The beach behind you is dark. You cannot see what lies in that sand. You have a handful. That handful is real. You can feel it. You can study each grain. But the darkness beyond? You have not searched it. You cannot search it. Most of it has already been recycled, pushed back into the earth, melted, reformed, erased. If something existed there, would you know? If someone built cities and sailed ships and watched their own stars, 50 million years before the first dinosaur, would any trace survive to reach your hands tonight? Would even a single grain of evidence make it into that small pile you hold against your chest? The answer is not obvious. The answer is not comfortable. The question that waits in that dark sand is simple. We have been assuming we are first because we found no predecessors. But what if finding nothing is exactly what we should expect? What if the absence itself tells us nothing at all? To answer that, we need to know what survives. Not buildings, not bones, not the things we usually look for. Something else. Something written in chemistry. Something locked in stone. What survives depends on where you die. This sounds simple. It is not. The difference between becoming a fossil and becoming nothing at all comes down to circumstances so precise, so unlikely, that most creatures who have ever lived simply vanished. Their bodies returned to soil, their bones dissolved to nothing, their entire existence erased as if they never were. We think of fossils as common. Museums display thousands of them. Documentaries show paleontologists pulling skeletons from cliffs as if the earth is overflowing with ancient remains. This creates an illusion, a dangerous one. For every dinosaur skeleton we have recovered, millions of dinosaurs lived and died without leaving a single bone. Not a tooth, not a footprint, not a scale. They walked the earth for lifetimes, raised young, hunted, fled, slept beneath strange stars. Then they died, and the planet absorbed them completely. Fossilization is like winning a lottery where almost none of the tickets were ever printed. You need to die in exactly the right place. A river delta, a tar pit, the floor of a shallow sea, somewhere with fine sediment that can bury you quickly. You need that burial to happen fast, before scavengers scatter your bones. Yet before bacteria reduce your tissues to mush, before the sun and rain and wind erase every trace of your body, then you need that sediment to compress into stone around you. You need minerals to seep through, replacing your organic material molecule by molecule. You need the resulting rock to survive. Not for 1,000 years, not for 1,000,000, for tens of millions, sometimes hundreds of millions. During all that time, the rock holding your remains must avoid being pushed deep enough to melt. It must avoid being thrust upward and worn away by weather. It must avoid being swallowed by the sea. It must avoid the slow grinding of continents as they drift and collide. And finally, after all of that, someone must find you. A creature must dig in exactly the right spot, at exactly the right depth, at exactly the right moment in history. Yet the odds of this chain completing are vanishingly small. The geological record is like a library where 99% of the books have been burned. The remaining 1% have been water damaged. Pages have been torn out. The text has been translated through 3 different languages. We are trying to read Earth's history through these fragments. Entire species existed and vanished without a trace. We know this because we can calculate it. When you look at how many fossils we have found and compare it to the diversity of life that must have existed to produce them, the gap is staggering. Perhaps 1 in 100 species that ever lived left anything behind. Perhaps fewer. Picture a forest filled with thousands of different creatures. Insects crawling through leaf litter, birds calling from branches, mammals burrowing beneath roots, fish swimming in nearby streams. Of all those species, only a handful might fossilize. Maybe just one, maybe none at all. The rest will disappear into the deep quiet of time, leaving no evidence they ever existed. How much have we lost? We do not know. That is the honest answer. We cannot count what is not there. We can only look at what survived and wonder what stories the missing pages held. Entire ecosystems may have flourished and collapsed in the gaps between the fossils we have found. Species that existed for millions of years, that filled ecological niches we cannot imagine, that lived complex lives in complex communities. Gone. Completely gone. Not because they failed, not because they were small or simple or unimportant, just because the circumstances of their deaths did not happen to include the narrow conditions required for preservation. The fossil record is not a complete history. It is a collection of lucky accidents. The creatures we know about are the ones who happened to die in the right place at the right time, whose remains happened to be buried before they decayed, whose tombs happened to survive the violence of deep time, whose graves happened to erode at just the moment we were looking. Consider what this means for us, for our cities, our buildings, our monuments. We think of our built environment as permanent, steel and glass and concrete rising toward the sky, highways stretching across continents. But look at where all of it sits. The vast majority of human construction is concentrated in a tiny fraction of the planet's surface. Our cities, our factories, our roads, all of it clustered on the same small patches of land, often near coasts, often near rivers, often in the very places most vulnerable to geological change. If nature struggles to preserve the bones of creatures that lived everywhere, in every environment, for hundreds of millions of years, what chance do our structures have? They are concentrated. They are fragile. They are made of materials the Earth knows how to break down. The organisms that failed to fossilize were not doing anything wrong. They were simply ordinary. They died in ordinary places, in ordinary ways. The Earth recycled them as it recycles everything. Our civilization might be the same kind of ordinary. We build in specific places. We use specific materials. We assume our works will outlast us. But the geological record has no memory of ordinary things. It only remembers the exceptions, the lucky few, the ones who died in exactly the right circumstances. What if we are not an exception? What if, given enough time, our cities face the same odds as any creature that ever lived, the same near-certain erasure, the same silent vanishing into the deep dark that swallowed 99% of everything that came before? What if we are not an exception? That question hangs in the air. But before we can answer it, we need to understand something fundamental about the planet we live on, something most of us never think about. The Earth is not a museum. It is a recycling system. Everything on the surface of this planet is temporary, not temporary on human timescales, temporary on geological timescales. The mountains you see from your window will not last. The continents will not last. The very rock beneath your feet is being unmade and remade in a cycle that has repeated since the planet was young. There are 3 processes doing this work, 3 forms of erasure operating simultaneously, patiently, relentlessly. They have been running for billions of years, and they are very, very good at what they do. The first is erosion. Rain falls on a mountain. Each droplet carries away a microscopic particle of rock. A single rainstorm removes almost nothing, but rain has been falling on mountains for hundreds of millions of years. Rivers carve canyons, not through force, but through repetition. The Colorado River has been cutting through rock for roughly 6 million years. The Grand Canyon is a mile deep, and that is the power of water given enough time. Wind does the same work more slowly. It lifts dust and sand, polishes exposed rock, carries away layer after layer. A granite peak exposed to wind and rain will lose perhaps a millimeter of height every 1,000 years. That sounds trivial. Over 10 million years, it loses 10 kilometers. The mountain ceases to exist, not through catastrophe, through patience. Anything built on that mountain goes with it, any evidence, any artifact, any structure, scattered atom by atom across the landscape until nothing recognizable remains. The second process is subduction. Picture the tectonic plates as a slow conveyor belt. The surface of the Earth is divided into massive sections, and those sections are moving, drifting apart in some places, colliding in others. And the rate is roughly the speed your fingernails grow, imperceptible on any human timescale, devastating on geological ones. At the edges of continents, something remarkable happens. Oceanic crust slides beneath continental crust. It descends into the mantle. The rock that was once the seafloor sinks deeper and deeper, subjected to increasing pressure and heat, until it melts. Whatever was embedded in that rock is unmade, destroyed at the molecular level, recycled into magma that will eventually rise again as new rock, carrying no memory of what it once contained. Here is the surprise that should unsettle you. No oceanic crust on Earth is older than 200 million years. None. The seafloor that existed when dinosaurs first appeared has been entirely recycled. Every square meter of it, subducted into the mantle, melted, reformed and subducted again. The Pacific Ocean has been remade multiple times since complex life began. We think of continents as ancient and permanent. They are neither. They are survivors of a process that destroys everything else. The ocean floors are constantly being devoured by the planet itself. Any evidence that rested on those floors is gone, not hidden, not waiting to be discovered. Gone. The third process is metamorphism. Sedimentary rock forms when particles settle and compress. Layers of sand become sandstone. Layers of mud become shale. If fossils form at all, they form here, in these layered deposits. But sedimentary rock does not stay sedimentary forever. As tectonic forces push rock deeper into the crust, pressure and temperature increase. The rock transforms. Sandstone becomes quartzite. Shale becomes slate. Limestone becomes marble. This is metamorphism, and it destroys information. The delicate structures that might preserve evidence of life, the chemical signatures, the microscopic traces, they are obliterated. The atoms rearrange into new crystal structures. Whatever story the rock once held is overwritten. A palimpsest where the original text has been scraped away and written over so many times that nothing of the first draft survives. These three processes work together. Erosion wears down what is exposed. Subduction devours what reaches the ocean floor. Metamorphism transforms what gets buried. The Earth has three ways to erase its past, and all three are always operating. 4.5 billion years. 400 million years of complex life, 150 million years of dinosaurs, 300 years of industry. Yet you heard those numbers before, but now you understand why they matter differently. 300 years is not just brief. It is a single breath in a windstorm. Our entire industrial civilization has existed for less time than it takes erosion to remove a meter of mountain. Our cities sit on rock that has been recycled dozens of times. The evidence of everything we have built exists on a surface that the planet continuously devours. This is not destruction by catastrophe. This is destruction by patience. The Earth has nothing but time, and time always wins. The rock beneath the Pacific has been subducted, melted, and reformed multiple times since the first fish crawled onto land. If a civilization had existed on those ancient seafloors, if they had built cities of coral and stone, yet if they had developed technology we cannot imagine, the evidence would be gone, completely gone, melted in the furnace of the mantle and recycled into fresh basalt that remembers nothing. We are standing on a planet that continuously devours itself. Every mountain you have ever seen is being unmade. Every ocean floor is being pulled into the abyss. Every layer of rock that might preserve evidence is being cooked into oblivion. The Earth does not preserve history. It recycles it, endlessly, remorselessly, without malice or intention. Just process, just physics, just the slow patience of a planet that has been doing this longer than life has existed. If physical evidence is destroyed on these timescales, if buildings erode and artifacts subduct and fossils metamorphose into unreadable marble, then what could possibly survive? But what trace could any civilization leave that would last tens of millions of years? Hundreds of millions? Is there anything that outlasts the recycling? Something survives. Not buildings, not tools, not monuments carved from stone. Those are already gone, eroded, subducted, metamorphosed into unreadable silence. Physical evidence cannot endure what the earth does to itself. But chemistry is different. Think of it this way. A manuscript can be scraped clean and written over. The original words disappear. The ink fades. The letters blur into nothing. This happens to rock. The earth writes new stories over old ones, again and again, until the original text vanishes entirely. Physical words fade, but some inks soak deeper into the parchment. Some leave stains that cannot be erased, residues that bleed through every layer, marks that persist even when the original writing is long gone. Our industrial civilization is writing in such ink right now. We are leaving a signature, not in concrete foundations that will crumble, not in steel towers that will rust, not in glass that will shatter and scatter. We are writing in chemistry, in isotope ratios, in synthetic compounds that have never existed on this planet until we made them. Since the beginning of the Industrial Revolution, human activity has released 550 billion tons of carbon into the atmosphere. That number is difficult to hold in your mind. Here is one way to approach it. If you could gather all that carbon into a single pile, it would form a mountain larger than any on Earth. We have added a mountain of carbon to the atmosphere in just over 2 centuries. And that carbon carries a fingerprint. Carbon exists in different forms. Carbon-12 and carbon-13 occur naturally, in a specific ratio. Fossil fuels come from ancient organic matter, buried and compressed over millions of years. That ancient carbon has a different ratio. When we burn coal and oil and gas, we release carbon that is isotopically distinct from what the atmosphere normally contains. The ratio shifts, not dramatically, not obviously, but measurably. And that shift gets recorded in the shells of marine organisms, in the limestone forming at the bottom of the sea, in coral reefs and cave formations and the bones of animals. The atmosphere changes, the ocean changes, the rock changes, and that change persists. A geologist 50 million years from now, examining sedimentary layers, would find an abrupt shift in the carbon isotope ratio, a sudden spike appearing in a single thin layer, the signature of something releasing enormous quantities of ancient carbon in a geological instant. That is one signature. There are others. Every year, human industry produces 400 million tons of plastic, polyethylene, polypropylene, polystyrene, molecules that do not exist in nature, are molecules that nature has no efficient way to break down. This plastic does not simply vanish. It fragments. It becomes smaller and smaller pieces. It enters rivers and oceans. It settles into sediment. It gets buried under new layers of mud and sand. Over millions of years, that sediment compresses into rock. The plastic compresses too. It becomes what some scientists call technofossils, thin layers of artificial material embedded in stone, a dark line of synthetic polymers that will mark this moment in the geological record. 65 million tons of aluminum, heavy metals concentrated in sediments at rates that dwarf natural processes, lead, mercury, cadmium, elements that exist in nature but never at these concentrations, never distributed like this, never accumulating in these patterns. The Earth has seen volcanic eruptions, asteroid impacts, massive flood basalt events that released toxic metals into the environment. But those events have signatures that geologists recognize. Gradual accumulation, specific isotope ratios, predictable distributions. Our signature is different, too sudden, too concentrated, too global, appearing everywhere at once, on every continent, in sediments from every latitude. And then there is the marker that cannot be mistaken for anything natural. In the 1950s, humans began testing nuclear weapons in the atmosphere. Those tests released radioactive isotopes that spread across the entire planet. Cesium-137, strontium-90, carbon-14 in elevated concentrations, plutonium-239. Plutonium-239 has a half-life of 24,000 years. That sounds brief compared to geological time, and it is. But here is what matters. Plutonium-239 does not exist in nature, not in measurable quantities. The planet does not produce it. Stars produce it. Supernovae produce it. But on Earth, before 1945, there was essentially none. Now there is. A thin global layer of artificial radionuclides, deposited in sediments around the world during a single decade of atmospheric testing. That layer will fade. The radioactivity will decay, but the daughter products, the elements that plutonium becomes as it breaks down, those will remain. The signature will blur over millions of years, but it will not vanish entirely. A geologist with sufficiently sensitive equipment could detect the remnants, could find the anomaly, could identify the moment when something on this planet began splitting atoms. Absence of evidence is not evidence of absence. You heard that phrase before. It was a statement about logic, about what we can conclude from what we fail to find. But now it takes on a different meaning. The Earth actively destroys evidence. It erases physical traces. It melts and folds and compresses and transforms. If you are looking for the ruins of an ancient civilization, you are looking for something the planet has spent millions of years trying to eliminate. Chemical signatures are different. They spread globally. They embed themselves in sedimentary layers forming everywhere at once. They do not require a single city to survive. They do not require a single artifact to remain intact. They require only that the chemistry of the planet changed, briefly, noticeably, in ways that left a permanent stain. Our current geological era, the moment we are living through right now, will be most clearly marked not by our cities, not by our monuments, not by anything we built. It will be marked by a thin dark line of plastic fragments, elevated heavy metals, radioactive isotopes, a chemical boundary, a scar in the rock. 50 million years from now, a geologist might find no trace of any human structure, no foundation, no tool, no bone. Nothing physical would survive that long. The recycling would be complete, but they would find the boundary, unmistakable, a moment when carbon isotopes shifted, when synthetic molecules appeared for the first time. When radioactive elements that do not occur naturally suddenly materialized across the entire planet. They would not know what built cities or wrote books or looked up at the stars. They would not know what we called ourselves or what we believed or what we hoped for, but they would know we existed. They would know because we left a scar. This raises a question that should feel uncomfortable by now. If we are leaving such signatures, chemical and isotopic anomalies that will persist for tens of millions of years, then we should ask something important. Would we recognize similar signatures in the ancient past? If another civilization had existed, long before the dinosaurs, long before complex life crawled onto land, would they have left the same kind of mark? A sudden spike in the rock, a chemical boundary, and a scar that cannot be explained by volcanism or asteroid impact or any natural process we understand. Would we know what we were looking at? 56 million years ago, the Earth ran a fever, not a gentle warming, not a gradual shift, a fever so intense that the planet's polar regions transformed into something unrecognizable. The Arctic Ocean, that frozen expanse we picture covered in ice and darkness, reached 23 degrees Celsius, warm enough to swim in, comfortable even. Picture it, where polar bears now hunt on ice floes, crocodiles once drifted through murky waters, where frozen tundra now stretches to the horizon, palm trees swayed in humid air, forests of cypress and fern spread across landscapes that today lie buried under permafrost. The poles were not cold, they were subtropical. Swamps stretched across regions we now call northern Canada, Siberia, Greenland. This event has a name. Scientists call it the Paleocene-Eocene Thermal Maximum, the PETM. It lasted somewhere between 10,000 and 20,000 years. In that window, global temperatures climbed 5 to 8 degrees Celsius above what came before. 5 to 8 degrees might not sound catastrophic. You experience larger temperature swings between morning and afternoon, but global average temperature is different. It represents the entire system shifting. Ocean currents altered. Weather patterns rewrote themselves. Ecosystems collapsed and reformed. The oceans absorbed much of the heat. They also absorbed carbon dioxide, which made them more acidic. Marine life suffered. Species that had thrived for millions of years suddenly found their shells dissolving. Their habitats transformed. On land, mammals migrated toward the poles, following the climate they needed to survive. Others failed to adapt and vanished. This was a mass extinction event, not as famous as the one that killed the dinosaurs 10 million years earlier, but real, devastating, written permanently into the fossil record as a boundary between two worlds. Here is what makes the PETM so relevant to our question. Buried in the rock from that era, geologists find a distinctive signal, a sharp shift in the ratio of carbon-13 to carbon-12. These are two versions of carbon, isotopes, and they occur in different proportions depending on where the carbon came from. Volcanic eruptions leave one signature. A decaying organic matter leaves another. Burning fossil fuels leaves yet another. The PETM signal shows a massive injection of light carbon into the atmosphere, the kind that comes from organic sources, the kind that comes from burning things that were once alive. Between 2,000 and 5,000 billion tons of carbon entered the atmosphere during this event. That range is uncertain because reading ancient rock is difficult, but even the low estimate is staggering. It dwarfs anything in recent geological history before humans arrived. Let me be absolutely clear here, because this is important. There is no evidence, none, that the PETM was caused by anything other than natural processes. Volcanoes, methane, orbital changes. These explanations work. They are almost certainly correct. And I am not suggesting ancient aliens warmed the planet. What I am suggesting is something more subtle and more unsettling. The leading hypotheses for the PETM point to natural triggers. Volcanic activity in the North Atlantic may have released enormous quantities of carbon dioxide. The heating could have destabilized methane hydrates on the seafloor, frozen deposits of methane that sit in sediments under high pressure. Warm them enough and they release their gas. Methane is a potent greenhouse gas. It would accelerate the warming, which would release more methane, which would accelerate the warming further. A feedback loop running out of control. These explanations make sense. They fit the evidence. They require no mysterious civilizations, no lost technologies, no wild speculation. Just the planet doing what planets sometimes do. Systems tipping past their thresholds. Natural cycles pushing into dangerous territory. And yet, the signature of the PETM is rapid carbon release, global temperature rise, ocean acidification, mass extinction, species migration toward the poles, ecosystems collapsing under stress. Look at that list again. It is precisely what an industrial civilization would leave behind. The carbon isotope shift, the warming curve, the extinction pulse, the acidified oceans. Every marker we expect from our own impact on the planet exists in the PETM record. If you showed a geologist the chemical signature of the PETM without telling them when it occurred, without any context, and asked them what could have caused it, burning fossil fuels would be a reasonable hypothesis. The data would support it. They would be wrong. The PETM happened naturally. We know this because we understand the mechanisms. We can trace the volcanic activity. We can model the methane release. The natural explanation fits. But here is the problem. The natural explanation fits our modern signature too. If scientists 50 million years from now examined the rock layers forming today, they would see a carbon isotope spike, rapid warming, ocean acidification, mass extinction underway. They could explain it naturally. Volcanic activity perhaps, methane destabilization, some tipping point in the carbon cycle. Their models would work. The physics would check out. They would be wrong. This is the epistemological trap. Natural catastrophe and industrial catastrophe can produce identical geological signatures. The rock does not record intent. It does not preserve motivation. It records chemistry, physics, the movement of atoms from one reservoir to another. A civilization burning through its planet's stored carbon looks exactly like a supervolcano doing the same thing. The difference is meaning, purpose, the existence of minds that chose to do something. And meaning does not fossilize. The PETM was natural. The evidence supports that conclusion. No serious scientist disputes it. But if it had not been natural, if something else had caused it, something that thought and built and burned, would the evidence look any different? We are left with a troubling possibility. Not that the PETM was artificial, but that we could not tell if it were. The signature would be indistinguishable. The geological record would show a sudden carbon spike, warming, extinction, and then recovery. Exactly what we see. And the planet heals. Given enough time, it always does. Temperatures stabilize. New species evolve to fill empty niches. The forests return, different but alive. The oceans recover their chemistry over hundreds of thousands of years. And the cause of the catastrophe becomes a question that the rock cannot answer. The rock cannot answer. That phrase should trouble you, not because it reveals a gap in our knowledge, but because it reveals something about how we look for knowledge in the first place. Science has a method, a rigorous, careful, extraordinarily successful method. When we encounter a phenomenon, we seek a natural explanation. We look for physical causes, chemical processes, geological mechanisms. We test hypotheses against evidence. We discard ideas that do not fit the data. This approach has transformed our understanding of the universe. It has given us vaccines and spacecraft, computers and antibiotics. It has revealed the age of stars and the structure of atoms. It works. When geologists examine a layer of ancient rock and find an anomaly, they ask a specific kind of question. They ask, which volcano might have erupted? Which asteroid might have struck? Which ocean current might have shifted? They look for the methane deposit that destabilized, the orbital variation that altered climate patterns, the continental drift that rearranged ocean circulation. These are good questions. They are the right questions. But consider what makes them the right questions. We ask them because they have answered similar questions before. Every anomaly in the geological record has eventually yielded to natural explanation: the great extinctions, the sudden climate shifts, the mysterious chemical layers. One by one, patient research has uncovered the mechanisms behind them. Volcanic winter, impact winter, anoxic ocean events. The method keeps working, so we keep using it. This is not a flaw. This is the strength of science. We build on what succeeds. We refine tools that have proven useful. We point our instruments at the places where we have found answers before. Picture a flashlight in a darkened room. You are searching for something important. The flashlight beam is bright, focused, effective. Whatever falls within that cone of light, you can see with remarkable clarity. The texture of surfaces, the color of objects, and the smallest details become visible when the light touches them. You sweep the beam across the floor, along the walls, into the corners. Everywhere the light falls, you can say with confidence what is there, but the room is large. The flashlight has boundaries. Beyond its reach, darkness persists. You can only see where you are looking. The rest of the room exists, but it remains invisible to you, not because it has vanished, because your light does not reach it. Scientific methodology illuminates whatever it is pointed at. It does this brilliantly. Centuries of accumulated knowledge have sharpened the beam, extended its range, refined its clarity. When we point it at natural processes, we see natural processes with extraordinary precision. We see the volcanic signatures, the orbital cycles, and the chemical fingerprints of biological and geological activity. When we find an ancient carbon spike, we point the flashlight at natural mechanisms. The beam reveals possibilities: volcanic outgassing, methane release from warming sediments, the slow oxidation of organic material, These mechanisms can produce carbon spikes. The physics works. The chemistry checks out. We have our explanation. The explanation is almost certainly correct. That is important to acknowledge. The natural explanations for geological anomalies are overwhelmingly likely to be the real explanations. Science reaches the right answers, but the reaching is shaped by what we assume is worth reaching for. If your keys fall somewhere beyond the streetlight's glow, you will search beneath the light. You will search thoroughly, carefully, methodically, and you will cover every inch of illuminated pavement. When you finish, you will conclude the keys are not there. This conclusion is accurate for the area you searched, but it tells you nothing about the darkness. You did not prove the keys do not exist in the shadows. You proved only that you could not see them there. We have been pointing our flashlight at natural processes for a very long time. Generations of geologists, climatologists, paleontologists, brilliant researchers asking careful questions, finding answers, building understanding. This is good science. This is how knowledge accumulates. But notice what question we never ask. When we encounter a carbon isotope spike from deep in the geological record, we do not ask whether someone burned fossil fuels. We ask which natural mechanism released the carbon. And the question about burning fossil fuels does not enter the inquiry. It sounds absurd. That feeling of absurdity matters. It shapes the investigation before the investigation begins. The question is dismissed not because evidence ruled it out, but because the question itself seems unreasonable. We filter it away before we even consider testing it. This filtering is usually correct. Most questions that sound absurd are absurd. We should not waste time investigating claims that have no supporting evidence. The burden of proof rests on extraordinary claims. This is a reasonable standard, yet the standard creates a pattern. When we find anomalies, we explain them naturally. When natural explanations fit, we accept them. When an alternative would require us to imagine something unprecedented, we do not imagine it. The methodology works perfectly. The blind spot remains undisturbed. Imagine a geologist examining an unusual chemical signature from 70 million years ago, an isotope ratio that seems odd, a trace element concentration that deviates from expectations. The geologist develops hypotheses. Perhaps a nearby meteor impact altered local chemistry. Perhaps unusual biological activity concentrated certain elements. Perhaps diagenesis, the chemical transformation that occurs after burial, created an artifact in the data. These hypotheses are tested. One of them fits well enough. The anomaly is explained. The geologist moves on. At no point did the geologist consider the possibility that the anomaly was artificial, not because evidence ruled it out, because the possibility was never entertained. The Earth is not a museum. It is an eraser. That phrase meant something earlier about the physical destruction of evidence, the grinding away of continents, the subduction of ocean floors, the slow, relentless recycling of everything that once existed. But there is another kind of erasure, the erasure that happens before we even look, the erasure of possibilities that our methodology does not permit us to consider. Even if evidence existed, even if some trace survived the geological processes that consume everything, we might not recognize it. We might explain it naturally. Our flashlight is bright, and we trust what it shows us. We have no reason to look into the dark. This is not a criticism. It is a recognition of how knowledge works. Every method of inquiry has boundaries. Every framework for understanding excludes certain questions. Yes, we cannot look everywhere at once. We cannot test every hypothesis simultaneously. We choose where to point the light based on where the light has worked before. The shadow remains. There is a simpler argument, one that cuts through all the uncertainty about fossilization and tectonic plates and chemical signatures. It goes like this. Beneath your feet, right now, there are vast deposits of coal, oil, natural gas. These resources formed hundreds of millions of years ago from the compressed remains of ancient plants and marine organisms. They have been sitting there, untouched, waiting. We found them, we extracted them, we burned them, and that burning built everything you see around you. The argument is straightforward. If another industrial civilization had existed before us, they would have found these deposits too. They would have dug them up. They would have burned them. They would have left the pantry empty. But the pantry is not empty. It was full when we arrived. Consider what it means to find oil. You drill into the earth and strike a reservoir that has been accumulating for 300 million years. The hydrocarbons pooled there in the darkness, sealed beneath layers of rock, compressed by the weight of ages. No one touched them. No one knew they were there. Until we arrived. Picture an abandoned house. You step inside and find the kitchen untouched. Cans in the cabinets. Bread on the counter, as somehow still fresh. A full refrigerator humming in the silence. The logical conclusion is clear. No one has lived here. If someone had stayed, they would have eaten. The untouched food proves the absence of inhabitants. This is the fossil fuel argument, the most straightforward case against any prior civilization. The resources are still there. Therefore, no one used them. It is a strong argument, perhaps the strongest, but it has limits, and the limits are worth understanding. Coal did not always exist. The vast deposits we mine today formed during a specific period in Earth's history, the Carboniferous era, 300 to 360 million years ago. Before that window, the world had no coal. The chemistry was different. The conditions were wrong. Think about what this means for our abandoned house. And the pantry was stocked 300 million years ago. Any resident who lived there before that date would have found empty shelves. They could not have eaten food that did not yet exist. Their presence would leave no trace in the pantry's inventory. If a civilization existed 400 million years ago, before the Carboniferous, they would have encountered a world without coal, without the vast petroleum reserves that would form much later from different organic material. They could have risen, flourished, collapsed, and vanished, and the full pantry would tell us nothing. The evidence of absence would simply be irrelevant. There is another possibility, perhaps more unsettling. What if a civilization never touched the pantry at all? Not because they lived before it was stocked, but because they found food elsewhere. And we assume that industrial development requires fossil fuels because our industrial development required fossil fuels. We burned coal to power our first factories. We refined oil to drive our engines. We extracted gas to heat our homes. The progression feels inevitable, almost natural, but it was not inevitable. It was one path among many. Geothermal energy sits beneath the surface of every continent. Hot springs and volcanic vents provide reliable power without any fossilized carbon. Iceland runs almost entirely on geothermal and hydroelectric sources today. A civilization that developed in a different geographical context might have followed that route from the beginning. Solar energy falls on every square meter of land. We developed the technology to capture it only recently, but the principle is ancient. Our plants have been converting sunlight into usable energy for billions of years. A civilization that understood biochemistry differently might have cultivated biological power sources, living machines, engineered organisms, systems we would not recognize as technology at all. They could have eaten from the garden. The full pantry would prove nothing. This is the quiet flaw in the strongest argument. It assumes that any civilization would look like ours, would follow our path, would make our choices. But why would it? We are one species on one planet, looking at one slice of history. We developed one approach to energy, one form of industry, one set of technologies. And now we search the geological record for evidence of ourselves. For someone who burned coal and drilled for oil and left the same fingerprints we are leaving, that we would not recognize a civilization that took a different path. Their signature would not appear in our pantry. It would not show up in the chemical profiles we know how to read. It would exist in some other register entirely, some language we have not learned to translate. The untouched fuel reserves are genuine evidence. They matter. They suggest that no civilization exactly like ours existed before us. No industrial society that followed our specific trajectory, that discovered fossil fuels and built an economy around burning them. That is meaningful. That narrows the possibilities, but it does not close them. The argument assumes we know what to look for, that we have identified all the signatures that matter, that the only path to technological civilization runs through coal mines and oil fields, and we are searching for keys beneath our own streetlight, looking for the evidence we know how to see. The pantry tells us one story, the garden might tell another, and there are other sources of knowledge, older than geology, more fragile than rock, human memory, the stories we tell each other, the myths that survive when everything else is lost. This is a different kind of evidence, softer, more fragile. It does not leave chemical signatures in stone or isotopic ratios in sediment. It lives in the space between generations, in the words spoken around fires, in the songs passed down from parent to child, and it has limits. Cultural memory is like a rope bridge across a canyon. For a few thousand years it holds. Stories pass from mouth to ear with reasonable fidelity. The names stay the same. So the places remain recognizable. The events keep their shape. But eventually, the fibers fray. The bridge sags. The connections weaken. What was once a clear account becomes a legend. The legend becomes a myth. The myth becomes a feeling without a name. Something happened. Something important. But the details have dissolved. Plato wrote of Atlantis in the 4th century BCE. He claimed it existed 9,000 years before his own time. That would place it roughly 11,000 years in the past from where we stand now. An island civilization of immense wealth and power, destroyed in a single day and night, swallowed by the sea. We cannot know what Plato actually believed, whether he intended the story as history or allegory, whether he received it from Egyptian priests as he claimed, or invented it to make a philosophical point. The text itself offers no certainty, but consider the mathematics of transmission. 9,000 years, 400 generations, roughly. The Atlantis story is like a game of telephone played across that span. Whatever signal started the chain has been transformed beyond recognition. Meaning shifts with each retelling. Names change, numbers round up or down. Geography warps to fit the storyteller's world. We cannot recover the original message. We can only note that the game was being played. And here is what strikes me. This pattern repeats everywhere. Flood myths appear in cultures that never met. Mesopotamian tablets describe a deluge that destroyed the world, with one family surviving on a boat. Greek traditions tell of Deucalion, and who rode out the rising waters with his wife. Hindu scriptures speak of Manu, warned by a fish to build a vessel. Chinese legends recall Gun and Yu battling catastrophic floods. Indigenous American traditions from dozens of separate nations describe waters covering the land. These cultures developed independently. They had no shared texts, no common ancestors in recent history, no obvious way to borrow each other's stories. Yet they all remember a flood. The edge of memory is like a fog bank. Everything beyond a few thousand years becomes shapes without names. We sense something out there. We feel the presence of events that mattered. But the details have dispersed into mist. This is the part that gets me. We have this intuition, shared across every culture, that something was lost, that there was a time before our time, or a world before our world, and it ended badly. Is this just psychology? Our pattern-seeking minds creating stories to explain a confusing universe? Probably. But what if some of those patterns are real? 12,000 years ago, the world was different. Massive ice sheets covered much of the northern hemisphere. Sea levels sat more than 100 meters below where they are today. That is the height of a 30-story building. The coastlines our ancestors knew are now underwater. The places they lived, the settlements they built along the shore, the communities that clustered near the abundant resources of river mouths and tidal flats. Gone. All of it. Drowned. The waters did not rise in a day. This was not a sudden catastrophe in the Hollywood sense. The melting happened over thousands of years, generation by generation. The shoreline crept inland. Grandchildren watched the sea swallow the fields their grandparents had farmed. Imagine living through that. Your village sits a day's walk from the water. Your parents tell you that when they were young, it was 3 days' walk. Your grandparents remember it being further still. Every generation, the sea takes more. This would sear itself into cultural memory. and over millennia, the slow creep might compress into a single terrible event. Time collapses in oral tradition. The gradual becomes sudden. The explanation shifts from geology to divinity. The waters rose because the gods were angry, because humans had sinned, because the world needed cleansing. The flood myths might encode something real, not a literal global deluge, but the lived experience of watching the ocean consume the land, passed down, transformed, stripped of context, dressed in new meaning, until all that remains is the emotional core. The waters rose. Everything we knew was lost. Oral tradition can preserve information for perhaps 2,000 or 3,000 years before degradation sets in. Beyond that, we are dealing with echoes, distortions, fragments. The myths are not scientific evidence. They cannot be. They lack precision, provenance, independent verification. You cannot peer review a legend. You cannot radiocarbon date a story told around a fire. But they are not nothing. They are the outer boundary of human memory, the place where history dissolves into feeling, the threshold beyond which we have only stone and sediment to guide us. Every culture we know of has myths of a lost golden age, a time when things were better, and when humans lived longer, built greater, knew more, and every culture has myths of how that age ended, in fire, in flood, in pride that summoned punishment. Perhaps this is simply how human minds work. We look at the ruins our ancestors left and assume they came from giants. We notice that the world is hard and imagine it was once easy. We project our longing backward and call it memory, but perhaps not. Perhaps some of those myths carry freight, real information, encrypted by time, warnings about what happened to people who came before, records of disasters that reshaped the world. We cannot prove this. We cannot extract historical data from a legend the way we extract isotopes from rock. The methodology does not exist. The source material is too degraded. And yet, somewhere out there, and in the darkness before recorded history, things happened. Civilizations rose and fell. Communities flourished and vanished. Knowledge was gained and lost. We feel the absence, even if we cannot name it. The fog bank extends beyond our sight, beyond our instruments, beyond even the chemical traces locked in ancient stone. But there are places where the mist clears, just slightly, where something emerges from the darkness that we did not expect, something that forces us to redraw the boundaries of what we thought we knew. In southeastern Turkey, a farmer's plow struck a stone. The stone the farmer's plow struck was not ordinary. It was carved, deliberately shaped, part of something larger. This was 1994 in southeastern Turkey, about 15 kilometers from the city of Sanliurfa. The land here is dry, rolling, and covered in scrub and wheat fields. Farmers had worked these hills for generations. Their grandparents had worked them. Their great-grandparents before that. Beneath their feet, buried under centuries of accumulated soil, lay the oldest known monumental architecture on Earth. The German archaeologist Klaus Schmidt recognized it almost immediately. What others had dismissed, he saw with fresh eyes. The carved pillar was not medieval. It was not Roman or Greek or Persian. It was something far older, something that rewrote our understanding of human history. They call it Göbekli Tepe. The name means belly hill in Turkish, a rounded mound rising from the landscape, unremarkable from the outside, the kind of feature you might walk past without a second glance. Schmidt did not walk past, he began excavating. And what emerged from the earth stunned the archaeological world. Massive T-shaped pillars carved from limestone, some standing 5 meters tall, some weighing 50 tons. That is the weight of a fully loaded semi-truck. These pillars were carved by hand, quarried from bedrock, transported to this hilltop, and erected in precise circles. And they were built 11,600 years ago. Let that number settle. 11,600 years. Stonehenge would not exist for another 6,000 years. The Egyptian pyramids were still 8,000 years in the future. Writing had not been invented. Agriculture had not been invented. The people who built Göbekli Tepe were hunter-gatherers. They followed herds. They foraged for wild plants. They had no permanent settlements, no cities, no kings. And yet they organized a construction project that required quarrying, carving, and raising 50-ton pillars. Picture what that means. These were not a few people stacking rocks. This required planning across years, maybe decades. It required feeding hundreds of workers who were not hunting or foraging while they labored. It required engineering knowledge to move stones that weigh as much as 10 elephants. It required shared purpose, shared vision, shared belief in something worth building. The standard model of human development said this was impossible. The textbooks taught a simple progression. First, humans invented farming. Farming created food surplus. Surplus allowed some people to stop producing food and specialize in other things. Specialization created priests and artists and architects. Her religion and monuments came last. The crowning achievement of settled agricultural society. Göbekli Tepe proved the textbooks had it backward. Hunter-gatherers built this place for what appear to be purely spiritual purposes. There are no living quarters, no storage rooms for grain, no defensive walls. The pillars are carved with animals, foxes, snakes, scorpions, cranes and wild boars and creatures that seem part human, part something else. This was a sanctuary, a gathering place, a cathedral in the wilderness, built by people we assumed were too primitive to imagine such things. They imagined them anyway, and then, roughly 8,000 years ago, they buried it, deliberately, intentionally. They filled in the circles, covered the pillars, smoothed the mound, and walked away. We do not know why. The site holds no answers, only the evidence of its own concealment. For the next 10,000 years, the secret held. Farmers walked over Göbekli Tepe. They plowed their fields above it. They built their houses nearby. They lived their entire lives mere meters from the most important archaeological discovery of the 20th century and never knew it was there. Generation after generation, century after century, empires rose and fell across this landscape. The Hittites, the Assyrians, the Persians, the Romans, the Byzantines, the Ottomans. None of them found it. A team of archaeologists actually surveyed this site in 1963. They noted the mound. They found some broken stone. They concluded it was an abandoned medieval cemetery, not worth excavating. They moved on. The truth waited another 31 years to be discovered. Yet consider what this means for our understanding of lost history. This is not a hypothetical. This is not speculation about what might be possible. This is documented fact. A massive complex of monumental architecture built by sophisticated people with advanced organizational abilities remained completely hidden for over 10,000 years, hidden in plain sight, beneath a farmer's field. The people who built Göbekli Tepe left no writing. They left no names. We do not know what they called themselves, or what language they spoke, or what stories they told their children. Everything they knew, everything they believed, everything that motivated them to undertake this staggering project is gone. Only the stones remain, and the stones were almost missed entirely. If Schmidt had not happened to visit in 1994, if he had not possessed the particular expertise to recognize what he was seeing, if the survey team in '63 had dug a little deeper, or if they had dug in the wrong spot and found nothing, confirming their assumption, the site might still be buried. The greatest archaeological discovery of our era might still be a farmer's field, unremarkable, unexcavated, unknown. This is not ancient history in the abstract sense. This is a lesson about what hides beneath the surface of the world, about how completely the past can be erased, not by destruction, but simply by forgetting, by layers of soil accumulating year after year, by assumptions that prevent us from looking in the right places, by accidents of timing and expertise and attention. Göbekli Tepe is a cathedral buried beneath a farmer's field, a proof that the past can hide in plain sight, waiting to be found. And if this was hidden for 10,000 years in a region that has been continuously inhabited, in an era we can actually study with archaeology, in a time frame where human memory should have preserved some trace of its existence, what else might be hidden? What else might be hidden? That question lingers. And to understand why it matters, we need to travel back, not to a buried temple, to a buried world. 12,800 years ago, Earth was warming. The great ice sheets that had covered much of North America and Europe were retreating. Glaciers that had stood for millennia were melting into rivers and lakes. The world was opening up. Forests were spreading north. Animals were migrating into new territories. For the humans alive at that time, yes, the future must have seemed bright, warmer, more abundant, more possible. And then it stopped. Something happened. We are still not entirely sure what. The leading theories point to a sudden disruption of ocean currents in the Atlantic. Cold, fresh water from melting glaciers may have poured into the sea, shutting down the circulation patterns that carry warmth from the tropics northward. Some researchers believe a comet or asteroid struck the ice sheet, triggering the cascade. The debate continues, but whatever the cause, the effect was catastrophic. In Greenland, temperatures plummeted by 14 degrees Celsius. That is not a gradual cooling over centuries. That is winter arriving and refusing to leave. The change happened within a human lifetime, perhaps within decades, perhaps faster. If you were a child when the warming ended, you would have grown old in a world that no longer resembled the one you were born into. This period has a name. We call it the Younger Dryas, after a small white flower, Dryas octopetala, an Arctic rose that thrives in cold, harsh conditions. When the temperature dropped, this flower spread across regions that had been temperate just years before. Its pollen appears in sediment cores from places where it had no business growing. A flower became a tombstone, a marker in the geological record that says, "Here, the cold returned." A flower as a monument to catastrophe. The Younger Dryas lasted roughly 1,200 years, more than 40 human generations, long enough that the warm time before would have faded from living memory within the first few generations, long enough that the world of ice and scarcity would have seemed permanent, eternal, the only world there had ever been. The stories of abundance and warmth would have transformed into legends, then into myths, then perhaps into nothing at all. Consider what was lost during this period. In North America, the megafauna vanished. Mammoths that had roamed the continent for hundreds of thousands of years. Mastodons, saber-toothed cats with fangs the length of your hand. Giant ground sloths that stood taller than modern elephants, all of them gone. Driven to extinction by the climate shift, or by the human hunters who competed with them for dwindling resources, or by some combination of both. The great beasts that had defined an entire continent simply ceased to exist, and with them, the Clovis culture disappeared. These were the people who had hunted the megafauna. They left behind distinctive stone tools, spear points with a particular fluted design that we can identify across thousands of archaeological sites. And then, those tools stop appearing. The culture that made them is gone. We do not know if they died or scattered, or simply changed so completely that we cannot recognize their descendants. We only know that one way of being human ended during the Younger Dryas. This is Earth's thermostat, being violently knocked from summer to winter in a single lifetime. Picture it. And you are born into a world of relative warmth. Ice sheets are retreating. The great animals are everywhere. Your people have developed sophisticated hunting techniques, tools, social structures. The climate is gentle, food is abundant, life is still difficult, but it is possible, it is good. By the time you are old, winter has come and will not leave. Your grandchildren will never know the world you were born into. When you try to tell them about the great beasts, about the warm summers, about the forests that grew where now there is only ice, they will listen politely, they will nod, and they will not quite believe you. It will sound like myth, like something an old person made up, like a dream of paradise that never really existed. And when you die, you will take your memories with you. And your grandchildren will tell their grandchildren. But the details will blur. The specifics will fade. Within a few generations, the warm time will be nothing but a story, a legend of a golden age, a paradise that was lost. This is how cultural memory breaks, not through deliberate erasure, through the simple passage of time under unbearable pressure. When survival becomes difficult enough, there is no energy left for remembering. The chain of transmission snaps. The stories stop being told. The knowledge vanishes. The younger dryas may have erased not just environments, but entire cultures and their memories. We think of human progress as a line moving upward, each generation building on the last, knowledge accumulating. But what if that line has been broken before? What if there were people before the cold came, and who had built something worth remembering, who had developed knowledge and skills and ways of understanding the world that we cannot imagine because no trace of them survived? Absence of evidence is not evidence of absence. If a relatively advanced society existed during the warm period before the Younger Dryas, the sudden climate catastrophe could have killed most of the population. The survivors would have been scattered, desperate, fighting to stay alive in a world that had become hostile overnight. They would not have had the luxury of preserving knowledge, of maintaining traditions, of telling stories to their children about how things used to be. They would have been too busy trying not to freeze, too busy trying not to starve. The chain of oral transmission would have broken, and once broken, it cannot be repaired. What is lost forever. We know for certain that human cultures were disrupted during this period. The archaeological record shows it clearly. Populations collapsed. Settlement patterns changed dramatically. Ways of life that had persisted for thousands of years simply ended. This is not speculation. This is documented fact. What we do not know is what was lost. Perhaps nothing of significance. Perhaps the cultures erased by the Younger Dryas were no more sophisticated than we already believe them to be. Perhaps the megafauna hunters were simply hunter-gatherers, and their disappearance, while tragic, represents no great loss of knowledge or achievement. Or perhaps not. Perhaps somewhere in the darkness of that 1200-year winter, libraries of oral knowledge were extinguished. Songs that contained astronomical observations, stories that encoded agricultural techniques, memories of places now drowned beneath the sea, ways of understanding the world that we have never recovered and never will. The flood myths that appear in cultures around the world, the stories of lost paradises, the legends of golden ages that ended in catastrophe. We tend to dismiss these as fantasy, as primitive attempts to explain natural phenomena. But what if some of them are memory, fragmented, distorted, passed down through so many generations that the original truth has been transformed beyond recognition, but memory nonetheless, fragments that survived when everything else was lost. The Younger Dryas ended as abruptly as it began. Roughly 11,600 years ago, the world warmed again. The ice retreated as the cold released its grip, and humans, those who had survived, began to rebuild. They built places like Göbekli Tepe. They invented agriculture. They started the long climb towards civilization as we know it. But they did not remember what came before. They could not. The break had been too complete. The winter had lasted too long. The world before the cold had become a dream, then a myth, then nothing at all. And we are left to wonder. In the darkness before the Younger Dryas, in that warm world of abundance and megafauna and retreating ice, what did our ancestors build? What did they know? What did they achieve? We may never find out. The evidence, if it ever existed, has been erased, not by malice, not by intention, simply by the slow grinding of time and the violence of a climate that shifted faster than memory could adapt. Some things are lost because they were never preserved. Some things are lost because no one survived to remember them. Some things are lost because they never existed in the first place. We need to talk about Lemuria, and Mu, and Atlantis as most people imagine it. A gleaming continent swallowed by the sea, towers and temples sliding beneath the waves, an advanced civilization erased in a single catastrophic night. These stories have power. They speak to something deep in us, the fear that greatness can be unmade, the hope that somewhere beneath the ordinary world lies something extraordinary, the suspicion that we have forgotten more than we remember. But some stories, no matter how beautiful, cannot survive contact with how the world actually works. Lemuria was born in the 1860s, as scientists noticed something strange about lemur fossils. These small primates appeared in Madagascar and in India, but nowhere in between. How did they get to both places? The simplest explanation seemed obvious. There must have been a land bridge, a continent spanning the Indian Ocean. They called it Lemuria, after the creatures that seemed to prove its existence. It was a reasonable hypothesis for its time. Like bloodletting or the four humours, it fit the evidence available. The logic was sound. The conclusion was wrong. We simply did not understand how the world moved. Then came plate tectonics, the realization that continents are not fixed. They drift, they split apart, they collide. India was once attached to Madagascar, not by a bridge, but as part of the same landmass. Then it broke free and travelled north, eventually crashing into Asia with enough force to raise the Himalayas. The lemurs did not need a bridge. Their ancestors lived on a single piece of land that later tore itself in two. Lemuria vanished, not beneath the waves, but from scientific possibility. There never was a sunken continent. There was only a gap in our understanding. Mu came later, 1860s and 70s. A man named Augustus Le Plongeon studied Mayan ruins and became convinced he had decoded their ancient texts. He believed they told of a great Pacific continent that sank beneath the sea, 12,000 years of advanced civilization, technology rivaling our own, all gone. The problem is that Le Plongeon could not actually read Mayan. His translations were fantasy, dressed in the clothing of scholarship. The texts say nothing about sunken continents, and they never did. Mu was invented from misreadings and wishful thinking. Later writers expanded the story. Books were written, maps were drawn, believers multiplied, but the foundation was never real. You cannot build truth on imagination, no matter how elaborate the architecture. Here is what geology tells us. It is not subtle. Oceanic crust behaves very differently from continental crust. They are made of different materials, different densities, different thicknesses. Continental crust floats higher on the mantle because it is lighter. It is like a block of wood floating on water. You can push it around, you can crack it, but you cannot make it sink. The ocean floor does subduct. It slides beneath other plates at the edges of oceans. But this process takes tens of millions of years, sometimes hundreds of millions. So the Pacific plate inches toward Asia. The Atlantic spreads wider every year by about the width of your fingernail. These are the timescales of mountain ranges rising and eroding away, not the timescales of human history. There is no physical mechanism by which a continent could sink in the timeframes these myths require. Not in 10,000 years, not in 100,000. The crust does not work that way. It never has. Plate tectonics did not simply cast doubt on these stories. It made them impossible. You can argue about interpretation. You can debate the meaning of ancient texts, but you cannot argue with the fundamental physics of how rock behaves under pressure. Continents do not sink like ships. They do not conveniently disappear beneath the waves to hide the evidence. The myths are dead. Geology killed them. And yet, there is something here worth saving. Not the specific claims. Those are gone. But the pattern, the structure, the recurring theme of lost worlds and rising waters. Because the waters did rise. This part is true. Around 5,600 years before the Common Era, the Mediterranean broke through a narrow strip of land we now call the Bosporus. The waters poured into a freshwater lake and transformed it into the Black Sea. Some researchers believe this happened catastrophically. A waterfall of salt water flooding a populated basin. Farms and villages swallowed over months or years. People lived on those shores. They would have fled the rising waters. They would have told their children what they saw. This is not Atlantis. There were no crystal towers, no advanced technology, and just farmers and fishermen watching their world disappear. But the trauma was real, the loss was real, and trauma has a way of echoing through generations. All around the world, coastlines moved. Communities that had lived by the sea for centuries found themselves underwater. The land where your grandmother was born became a fishing ground. The hills where your ancestors are buried became islands, then reefs, then nothing. These were not myths. These were memories. The stories grew in the telling. Details blurred, timelines compressed. A village became a city became a civilization became a wonder that outshone everything the survivors had ever built. That is how memory works. Not maliciously, not even consciously, just the natural drift of stories told too many times. So the flood myths that appear across cultures may not remember any single event. They may not preserve accurate details of what was lost, but they preserve something true nonetheless. The knowledge that the sea once rose, that what seemed permanent was not, that entire ways of life can vanish beneath the waves. We look at these stories and see fantasy. Perhaps we should look harder, behind the impossible geology, behind the invented continents, behind the gleaming spires that never existed. There might be a grain of truth too small to see clearly, not proof of advanced civilizations, not evidence of lost technology, just the echo of genuine catastrophe, distorted by the passage of time until the original shape is barely recognizable. The human heart needs these stories. We want to believe that somewhere in the deep past, our people built wonders. We want to believe that time is not just an engine of destruction. We want lost worlds because we fear our own world might someday be lost. This longing is not weakness. It is not ignorance. It is the same impulse that sends us into archives and archaeological digs, the same need to know what came before. The myths are wrong in their specifics. Lemuria never existed. Mu was a mistranslation. No continent sank beneath the waves in recorded memory. But the questions behind the myths remain. What have we truly forgotten? What lies beneath the surfaces we walk on every day? What would we find if we could somehow peer through time? These are not foolish questions. They are exactly the questions that science was invented to answer. And there is a way to ask them, a rigorous way, a method that does not require sunken continents or misread texts. A thought experiment proposed by actual scientists, designed to explore what we could know and what we could never know about a civilization buried in deep time. There is a way to ask them, and it begins with something no one expected to find. In 1972, a technician at a French nuclear facility noticed something strange. Uranium samples from a mine in Gabon, in Western Africa, had the wrong ratio of isotopes. Not by much, a fraction of a percent. But uranium is one of the most precisely measured substances on Earth. Even a tiny deviation demands explanation. The explanation, when it came, rewrote what we thought we knew about nuclear fission. 2 billion years ago, in the rocks of a place called Oklo, something remarkable happened. A groundwater seeped through cracks in the stone. It filtered down into deposits of uranium ore that were far more concentrated than anything we mine today. The water slowed the neutrons. The neutrons split atoms. The atoms released heat. The heat drove away the water. The reaction paused. The rock cooled. The water returned. And it started again. This cycle repeated for hundreds of thousands of years. Not once. Not briefly. For longer than humans have existed as a species, by a factor of 1,000. Natural nuclear reactors, running themselves in the deep silence of prehistoric Africa. No engineers designed them, no containment vessels held them, no minds conceived of them. Just physics, just geology, just time, and the right conditions. The reactions produced the same fission products that modern reactors produce, and the same isotopes, the same decay chains, the same signatures that we would recognize in any nuclear facility on Earth today. Think about what that means. For decades, we assumed nuclear fission was a clear marker of technology, a signature that could only appear if intelligent beings built machines to split atoms. If we found evidence of fission products in ancient rock, we would have assumed a civilization put them there. Oklo proves we would have been wrong. The universe figured out nuclear fission 2 billion years before the first human was born. It did not need us. It did not wait for us. It simply followed the rules that govern matter and energy, and those rules, under the right circumstances, produce reactions we thought belonged only to us. This is not a criticism of human achievement. Our building a controlled nuclear reactor remains one of the most sophisticated engineering accomplishments in history. The The scientists who first sustained fission in 1942 changed the world, but they did not invent fission. They discovered it. They harnessed something that already existed, something the universe had been doing, in its own way, for billions of years before they were born. Sit with that for a moment. Radioactive isotopes are like a ticking clock. We can hear but cannot see the hands of. We know something happened. We can measure the decay. We can count the products. We can trace the chains backward through time. What we cannot always know is what caused it. A signature in the rock might mean technology. It might mean a civilization that harnessed atomic power. And it might mean intelligence and intention and all the things we associate with minds like our own. Or it might mean water and uranium and the patient mathematics of neutron moderation. The rock does not distinguish between these possibilities. The isotopes do not carry labels. They simply are what they are, silent witnesses to events whose causes we must infer. This cuts in multiple directions. On one hand, it means natural explanations deserve priority. When we find something unusual in the geological record, our first assumption should be that nature produced it, because nature, as Oklo demonstrates, is capable of remarkable things, complex things, things that seem, at first glance, to require design. On the other hand, it means our task becomes extraordinarily difficult. If nature can mimic the signatures of technology, then distinguishing one from the other requires more than just finding an anomaly. It requires understanding the anomaly well enough to rule out every natural possibility. And ruling out every natural possibility is perhaps impossible. Here is the question that haunts this entire thought experiment. If we found an ancient anomaly that looked artificial, would we recognize it for what it was? Or would we, correctly following our methodology, find a natural explanation and move on? Science works by assuming natural causes until proven otherwise. This is not a weakness. It is the source of science's power. It prevents us from seeing faces in clouds and calling them gods. It keeps us honest. But it also means that if something artificial did exist in the deep past, we might explain it away. We might look at the evidence and say, yes, this is unusual, but here is a natural process that could produce it. We might be right, we might be wrong, and we might never know which. The Oklo reactors were recognized as natural because we understand the physics well enough to reconstruct what happened. We can trace the geology. We can model the reactions. We can explain why that particular place, at that particular time, produced that particular result. But what about signatures we do not understand as well? What about anomalies that sit at the edge of our knowledge, where the distinction between natural and artificial blurs into uncertainty? The answer is uncomfortable. We do our best. We follow the evidence. We remain humble about what we do not know, and we acknowledge that some questions may be unanswerable. This is not defeat. It is honesty. The universe is under no obligation to make its history legible to us. It recorded events in stone and chemistry and isotope ratios, but it did not include footnotes. It did not label the exhibits. It simply preserved what it preserved and left us to interpret the fragments. Two scientists understood this. They looked at the problem of detecting ancient civilizations and asked a deceptively simple question. Not whether such civilizations existed, but whether we could ever know. They asked whether we could ever know. And that question, more than any answer, is what matters here, because the question forces us to confront something uncomfortable, something we rarely stop to consider. We have been assuming. For generations, scientists have looked at the geological record and seen silence. No ancient factories, no buried highways, no fossilized machines. And from that silence, they drew a reasonable conclusion. No one was here before us. The earth was empty of minds until we arrived. But here is the thing about silence. It can mean two very different things. When you enter an empty room and find no one, you conclude the room is unoccupied. That seems obvious. That seems logical. But what if the room has no windows? What if the door has been sealed for millions of years? What if everything inside has been slowly ground to dust by the patient work of time and pressure and chemistry? the emptiness tells you nothing, except that emptiness is what remains. The silence in the stone is exactly this kind of silence. It is an answer that could mean no one was here, or it could mean we cannot hear them anymore. Both interpretations fit the evidence. Both are consistent with what we observe, and we have no way to distinguish between them, not because the question is meaningless, but because the record itself has been compromised in ways we are only beginning to understand. A deep time is an ocean where human history is a single wave that has already crashed and receded. We stand on the shore and see only flat water. The surface is calm. The horizon stretches forever. Was there ever another wave? Did something else rise and fall in those depths before us? The sea keeps no record. The waves do not remember each other. This is not a metaphor about the limitations of memory. This is a description of physical reality. The earth does not preserve the past, it recycles it. Erosion, subduction, metamorphism. These are not occasional events. They are continuous processes. They have been running for billions of years. They will continue running long after we are gone. The earth is not a museum. It is an eraser. That phrase has been building through everything we have explored. And now it arrives with its full weight. Because what it means is that the absence of evidence is not simply a gap in our knowledge. It is a feature of the system. The geological record is not incomplete by accident. It is incomplete by design, by the design of physics and chemistry and time itself. We do not have access to the past. We have access to the fragments that survived the erasing. And those fragments are not a random sample. They are a biased sample. Certain conditions preserved certain things. Everything else was lost. Consider what this means for our search. We have never systematically looked for artificial signatures in the deep past. Not really. Not with protocols designed for that purpose. We have looked for fossils. We have looked for chemical anomalies. But we have looked for extinction events and climate shifts and volcanic eruptions. But we have not looked for technology, because the question seemed absurd. Why would we search for something that obviously was not there? That is circular reasoning. We assumed no one was here because we found no evidence. But we found no evidence partly because we were not looking. And we were not looking because we assumed no one was here. The absence of evidence might simply be evidence of absence of inquiry. This is not an accusation. Scientists do not waste resources searching for things they have no reason to believe exist. That is not bias. That is efficiency. You do not sweep a room for dragons when there is no indication dragons are present. But it does mean something important. And it means we cannot point to the silence in the stone and claim it proves anything. We cannot say with confidence that we have ruled out the possibility, because ruling something out requires actively testing for it. And we have not done that. Not at the scale the question deserves. The silence is real. The interpretation is ours. Let that distinction breathe for a moment, because it matters. The rocks are what they are. The gaps are where they are. The chemical traces either exist or they do not. None of that is in question. What is in question is the meaning we assign to it, and meaning is not preserved in geology. Meaning is not something we dig up from sediment layers. Meaning is something we bring to the evidence, something we construct from the patterns we see, or do not see. The stone is silent, and that silence stretches back through layers of time so deep that human comprehension falters at the edge of it. We peer into the darkness and see nothing looking back, no reflection, no response, just the patient indifference of mineral and pressure and heat. Maybe that silence is the answer. Maybe it really does mean we are first. That possibility is real and should not be dismissed. The Earth may have waited billions of years for minds to emerge, and we may be those minds. But maybe the silence is something else. Maybe it is the sound of erasure, the sound of evidence being slowly, relentlessly, comprehensively destroyed by the very planet that once held it. Maybe the silence is not absence. Maybe it is loss. We cannot know. Not yet. Perhaps not ever. But we can at least ask the question properly. The two scientists understood this. They looked at everything we have explored. The erasure, the bias, the methodological blind spots, the way our assumptions shape what we search for. And they decided to formalize the question, to give it a name, to treat it not as fantasy, but as a legitimate scientific thought experiment. They called it the Silurian hypothesis. The name itself is a joke. That is the first thing worth understanding. The Silurians are fictional. They come from Doctor Who, intelligent reptiles who supposedly evolved on Earth billions of years before mammals existed, then went into hibernation beneath the surface. They are not real. They never were. And yes, two scientists at the peak of their careers looked at this question and decided to name their hypothesis after them. Gavin Schmidt, a climatologist at NASA. Adam Frank, an astrophysicist at the University of Rochester. Not fringe thinkers, not conspiracy theorists, researchers with decades of published work between them. And they chose a name from a British television program about a time-traveling alien in a blue box. Scientists have a sense of humor, but beneath the playful name is a serious question that no one had thought to formally ask before. The paper was published in 2018. It appeared in the International Journal of Astrobiology, peer-reviewed, methodologically rigorous, and it asked something deceptively simple. If an industrial civilization had existed on Earth tens of millions of years ago, how would we know? Not whether one existed. How would we know? That distinction matters enormously. The Silurian hypothesis is not a claim. It is a mirror. Schmidt and Frank did not write a paper arguing that ancient civilizations existed. They wrote a paper demonstrating that we have no reliable way to prove they did not. This is a profound difference. It is the difference between saying the room is empty and saying we cannot see into the room. One is a statement about reality. The other is a statement about the limits of our vision. The hypothesis does not argue for anything hidden in the deep past. It does not propose secret cities beneath the crust or forgotten empires erased by time. It proposes something far more unsettling. It proposes that our tools are inadequate, that the methods we use to study deep time were never designed to answer this question, and that we have been looking at the geological record with instruments calibrated for one purpose and expecting them to detect something entirely different. Absence of evidence is not evidence of absence. That phrase appears throughout their work, not as a shield for wishful thinking, as an acknowledgement of methodological humility. We cannot claim to have ruled something out if we never tested for it properly. The paper walks through what an ancient industrial signature might look like: carbon isotope shifts, synthetic molecules, unusual concentrations of rare elements, extinction pulses, climate anomalies, each one examined, each one found wanting, not because the evidence would not exist, but because it would be transformed beyond recognition, compressed, heated, diluted, subducted, erased. Yet the conclusion is not that ancient civilizations existed. The conclusion is that our current detection methods would likely miss them even if they had. This might sound like intellectual gamesmanship, a clever thought experiment with no practical application. But Schmidt and Frank had a deeper purpose. They were thinking about other worlds. The search for life beyond Earth has expanded dramatically. We have found thousands of planets orbiting distant stars. Some of them sit in the habitable zone, where liquid water might exist on the surface. The next step is to look for biosignatures, chemical traces that suggest life, and beyond that, technosignatures, evidence of technology, industry, intelligence. But here is the problem. If we cannot reliably detect technosignatures on our own planet, in our own geological record, as with direct access to the rocks and sediments and chemical layers, what hope do we have of detecting them across light years of empty space? What arrogance leads us to believe we could spot the fingerprints of alien industry on a world we cannot touch, when we cannot even be certain about the world beneath our feet? The Silurian hypothesis was never about Earth at all. It was about calibrating our expectations, about recognizing that the tools we build are limited by the questions we think to ask. We designed our instruments to study planets. We designed our methods to study chemistry and atmospheres and orbital mechanics. We did not design them to detect civilizations that may have existed and vanished long before we arrived. The mirror reflects both ways. Schmidt and Frank published their hypothesis as a thought experiment, a provocation dressed in academic language, a way of saying to the scientific community, we do not know what we think we know. We have assumptions embedded so deeply in our methodology that we have forgotten they are assumptions at all, and those assumptions may be blinding us. The paper does not demand belief, it demands honesty. It asks us to sit with the discomfort of not knowing, to acknowledge that the silence in the geological record might mean exactly what it appears to mean, or it might mean something else entirely, and we currently lack the ability to distinguish between those possibilities. That is the gift hidden inside the joke of the name, a reminder that science is not about certainty. It is about refining our ignorance, about building better questions before we build better answers. The Silurians from Doctor Who are fiction. They live in scripts and special effects and the imaginations of viewers. But the question they represent is real, and it will not go away simply because we find it uncomfortable. Could something have been here before us? Something that rose and fell and left behind only silence? The honest answer is that we do not know. The honest answer is that we may never know. And the honest answer is that this uncertainty should not frighten us. It should focus us. It should remind us that the universe is vast and old and strange and under no obligation to make itself legible to creatures who have been asking questions for the blink of an eye. The Silurian hypothesis does not claim ancient civilizations existed. It claims something more important, and it claims that we have not yet earned the right to say they did not. We have spent this time looking backward, searching for ghosts in the stone, wondering if something walked here before us, built and dreamed and vanished into silence. But there is another question, one we have been circling without speaking directly. What are we leaving behind? Right now, in this moment, our civilization is writing its own story into the rock, not in words, not in monuments, in chemistry, in absence, in death. The species are vanishing, not at the slow background pace that has always been part of life on Earth, not the quiet turnover of evolution doing its patient work, something else, something faster. The current extinction rate is 100 to 1,000 times higher than what happens naturally, and that is not a number to glance at and move on. That is a wound. 40,000 species are currently threatened with extinction. 40,000. Each one the result of millions of years of evolution. Each one a solution to the problem of being alive, and we are erasing them faster than we can even count them. This is the 6th mass extinction in Earth's history. The first 5 were caused by volcanism, asteroid impacts, shifts in ocean chemistry. This one has a different cause. This one is us, and the rock will remember, long after our cities have crumbled to dust, long after the last book has rotted and the last hard drive has corroded into meaningless metal, long after every digital record, every photograph, every recording of a human voice has dissolved back into noise. The chemical signature will remain. Of future geologists, if there are any, will find a thin boundary layer in the rock, a dark line where the sediments change, elevated carbon isotopes from our burning of fossil fuels, tiny fragments of plastic, broken down but never truly gone, a distinctive spike of radioactive fallout from weapons testing, and beneath that line, a sudden drop in biodiversity, the extinction signature. This layer will be thin, perhaps a centimeter, perhaps less. Our entire existence, everything we have built and loved and destroyed, compressed into a geological whisper, but it will be a whisper that screams. Imagine a geologist holding a core sample 50 million years from now, a cylinder of rock drilled from what was once a seabed. They slide their finger along the layers. Millions of years pass beneath their touch, and then they reach a strange band, carbon-enriched sediment unlike anything above or below it, synthetic particles that should not exist in nature, the chemical residue of something that burned very hot and very fast. They might wonder what happened here. They might run tests, analyze ratios, debate with colleagues, and they might find no answer. just the evidence that something changed, violently, briefly, and then was gone. This is our tombstone, written in plastic and plutonium. We think about legacy in terms of what we are proud of, the art we create, the science we discover, the music, the literature, the monuments to our better nature. We imagine being remembered for our achievements, but the only legacy guaranteed to survive geological time is our destruction. The carbon spike, the mass extinction, the synthetic materials that will outlast everything else we have ever made. We will be remembered, if we are remembered at all, as a catastrophe, a brief chapter of violence in the Earth's long story. The sixth death. I find this both terrifying and strangely comforting. Terrifying because everything we love will be erased. Every painting, every symphony, every poem written to someone who is now dust. The face of everyone you have ever known, gone. The rock does not preserve sentiment. It preserves chemistry. And our chemistry is the chemistry of burning and dying. But comforting because it means we are part of the story. A brief, bright, destructive chapter. But a chapter nonetheless. The Earth will continue after us. The tectonic plates will keep moving. New mountains will rise. New oceans will fill. And something will come after. Something will evolve in the silence we leave behind. Maybe something will look at that dark line in the rock and wonder about us. The way we wonder about what came before. Every building will be gone. Every digital record. Every photograph of every face that ever smiled into a camera. But the scar will remain. Our mark on the world. Not the mark we wanted to leave. Not the mark we imagined. Just the mark we actually made. A thin, dark line where the world changed. A chemical memory of the brief time when something walked here. Something that burned fossil fuels and made plastic and drove 40,000 species toward oblivion. Something that dreamed of being remembered for its greatness, and will be remembered, if at all, for its cost. The Earth keeps its own records, and those records are merciless. But perhaps that is not the end of the story. Perhaps it is simply the story itself. Come back to the beach, the dark beach at night, stretching behind you into blackness you cannot see. You have been here before, at the beginning, but now you carry something different. Now you understand. The beach has been here for 4.5 billion years. Waves have crashed upon it that left no trace. Footprints have been made in its sand, and the tide has erased them. Creatures have walked here that we will never name. Perhaps civilizations have risen somewhere in that darkness. Perhaps they asked the same questions we are asking now. Perhaps they wondered if they were first. The handful of sand is still in your hand. 10,000 years of human civilization. Everything we have ever built. Every city, every song, every face that ever smiled into another face. It is not special. It is simply the sand that happens to be in your hand, in this moment, before the next wave comes. And that is enough. That has to be enough. 4.5 billion years. 400 million years of complex life crawling and swimming and flying across this ancient world. 150 million years of dinosaurs. 300 years of industry. These numbers meant something different when we started. Now they carry weight. Now you feel them in your chest. The Earth is not a museum. It is an eraser. This was never a threat. It was always just the truth. The mountains rise and the mountains fall. The oceans fill and empty. The continents drift like slow dreams across the surface of a sleeping world. And through it all, here the stone forgets. We asked whether we might not be first, whether something came before us, whether the silence in the rock hides more than we can know. The honest answer has not changed. Absence of evidence is not evidence of absence. We looked for what would survive. We found almost nothing. Not buildings, not art, not memory, only chemistry, only the faint signature of burning and dying, written in isotopes that even time struggles to erase. The silence in the stone is not an answer. It never was. It is a question that will never be fully resolved, a door we cannot open, a room we cannot see into. But here is what has changed. We are no longer afraid of the silence. We accept it. We are here now. We are asking these questions now. We are the universe becoming aware of its own forgetting. And someday we will be gone, and the earth will continue its slow work of erasure. The waves will keep coming. The sand will shift. Perhaps something will come after us. Perhaps they will find our thin, dark line and know that something was here. They will not know what we loved. They will not know what we feared. They will not know what we dreamed when we looked up at the stars and wondered if we were alone. But they will know we existed. And perhaps that is enough. The silence in the stone is our future, as much as it may be someone else's past. We are not separate from this story. We are part of it. A brief chapter, a single breath in a life that spans billions of years. We may never know if we are first. We will certainly not be last. And there is peace in that, in being part of something so vast that our chapter is both infinitely meaningful and infinitely small. In knowing that the questions matter, even when the answers do not come. The beach stretches behind you into darkness. The sand is in your hand. The wave is coming. Close your eyes now. Let the silence hold you.